guys, how you doing? This is Walker Joseph with another Top Tech HVAC training videos. As you can see, I'm in the classroom setting. I have an air conditioning unit. In this video, before we get into the video, if you like the video, please like and subscribe. Click the link below. All right, I'm going to be describing two different types of air conditioning units. As in refrigeration, refrigeration is the process of removing heat to a place to make little to no difference. Air conditioning is an application of refrigeration. I'm going to be demonstrating you the refrigeration cycle on two types of equipment. One, this is a package terminal unit, also called PTAC for abbreviation. As you can see, I have my compressor, which is part of the system. It's going to go two lines from the compressor. Your discharge line will be connecting to your condensing coils here. This will be obviously condensing the refrigerant, which will be saturated. When it gets towards midway, with the aid of your fan motor, is going to condense that refrigerant, turning it to be liquefied. Once that is liquefied, it's going to then transfer into right here. This is going to be your liquid line. Your liquid line will travel, and this will be considered your metering device. Remember guys, you have four major components: compressor, metering device, evaporator, and condenser coils. You're going to have your condenser coils going to travel here, your metering device, I'm sorry. Now the metering device basically is going to regulate the flow of liquid refrigerant. Your condenser is going to change the state because you're going to have a high temperature, high pressure, superheat. And then at the bottom of your condenser coil is going to be subcool liquid. And changing that vapor, high temperature vapor, into a warm subcool liquid. Predominantly people say it's a high temperature vapor, but high temperature liquid, but it's predominantly a low warm temperature liquid. It goes into your metering device here. It dramatically drops the pressure and drops the temperature. And then it goes into your evaporator. With the aid of the fan motor, the evaporator's sole purpose is to absorb the heat. At the bottom of the refrigerant of the coil is going to be a saturated 75% liquid, 25% vapor. By the time it gets midway of the evaporator coil, it's going to be saturated 50-50, 50% liquid, 50% vapor. When it leaves your evaporator coil, it's going to be 100% superheat. Now, actually, what is superheat? Superheat, anything above your evaporator saturated temperature. Now, I'm going to be explaining that same cycle on a typical air conditioning system here. An air conditioning system, you're going to have your indoor coil, which is, this will be your air handler unit. You're going to have your thermostat. I'm going to turn this system on. Now, let's go ahead and explain it here. On your indoor coil, when you turn the air conditioning on auto and cool, it's going to absorb heat from the indoor ambient temperature. When it absorbs that heat, the refrigerant is a chemical is going to begin to boil in that process. When that refrigerant begins to boil, changing it from liquid, saturated liquid, to 100% superheated vapor. Now, the heat that's inside the space, you're going to use evaporator approach temperature. Now, the suction line here is going to be connecting your evaporator to your compressor. The suction line is a larger diameter tubing, insulated, because you do not want to pick up any additional heat, superheat. Therefore, you insulate it. That suction line is going to travel, is going to connect your compressor. Then you're going to go outside, and then you're going to have your condensing unit. In your condensing unit, you're going to have your compressor motor, Your compressor is going to be located inside here. Your compressor is a vapor pump. It's the heart of the system. You do not want your compressor to pump any liquid. Your compressor only supposed to pump vapor refrigerant. Now, it's going to take in that suction gas, low pressure, low temperature. It's a pressure increaser. So therefore, with that pressure increaser, it's going to bring it to a high temperature, high pressure, superheated vapor. Now, also keep in mind, the compressor is actually adding heat as well, heat of compression. The condenser coil, which is this whole thing here, is going to go ahead and go to 3 phases. The first phase is going to de-superheat. By the law of thermodynamics, heat travel from a high temperature to a low temperature by the outdoor ambient. Let's say the outdoor ambient is about 90 degrees. Using the approach temperature, the discharge line, basically the line that's connecting the compressor to the condenser coil, that would be the hottest temperature or the hottest point of the refrigeration cycle. If I was to open up this, you will actually see it. When that discharge line is the hot, it's going to dissipate its heat automatically to the surrounding outdoor ambient. Heat travels in 3 forms: conduction, convection, and radiation. With the aid of my condenser fan motor, it's going to cause a forced convection because air is a poor medium when it comes to transferring heat as opposed to water. So with the aid of the fan motor, it's going to cause a forced convection because I don't have a large surface space of coil. It's going to reject all the heat and dissipate it, all the heat to the surrounding air. And by the time it gets midway of the condenser coil, it's going to be saturated. Now, what is saturated? Saturated means it's a mixture of liquid and vapor refrigerant. By the time it gets to the bottom of the condenser coil, I'm going to be 100% liquid. And how do we know that we're 100%? We're going to do a formula. That formula is called subcooling formula. Subcooling formula is going to be measured right on your liquid line using our manifold gauges to give us saturation temperature on the high side. System must be running. We're going to give it a minute. Let the system run. We're going to check the subcooling. Now, subcooling means the prefix of sub means below. We want to cool the refrigerant below its condensing saturation temperature. Anything below condensing saturation temperature would be subcooling. So right here, we're going to have a subcool liquid right at the bottom. That subcool liquid is going to go and travel. It's going to connect outdoor unit to indoor unit. Don't mind this bucket here, this little cup. We're going to take that suction, that liquid line. Predominantly, you'll have a filter dryer in the system. Filter dryer will remove all the moisture that's in the system. So now you have this liquid coming in, and it's going to travel, and it's going to enter into our next component, which is our metering device. Your metering device is going to be these here. There's 3 different types of metering device. You're going to have a thermostatic expansion valve. You're going to have a fixed orifice, or you're going to have a cap tube. This will be a fixed bore orifice with distributor tubes. You see these capillary tubes? Those are my metering device. It has a fixed orifice in there. If it was a thermostatic expansion valve, it would have a sensing bulb that would sense the pressure and temperature of the suction line. Now, when it goes into your metering device, the purpose of the metering device, it needs to control the liquid refrigerant that's going into my evaporator. And it does that by dropping the pressure and dropping the temperature dramatically. Therefore, it will go ahead and increase loud. So now, with that being said, we're going to go ahead and find out if everything is working. So now, we're going to go ahead and turn the system on and see and check the other components. Now, before we check the other components, we want to make sure that for this demonstration, I open up the panel. When the system is running, we want to make sure we close the panel because we're only supposed to suck air from one direction, which is going to be from the bottom right here. Now, by the time it leaves the metering device, it's at a, once it enters the metering device, it's at a high temperature subcooled liquid. When it leaves the metering device, it's at a low temperature. So the metering device will be a pressure dropper, as opposed to the compressor will be a pressure increaser. So now we have this. We have our capillary tubes, which is our metering device. It's going to go to the coil. By the time it's here, it leaves the metering device, it's at 75% liquid, 25% vapor. It's a flash gas. By the time it gets right here to midway, we're at 50% liquid, 50% vapor. When it gets to the on the top of the metering device, we're at 100% vapor. We should be at 100% vapor. Now, let's say my evaporator temperature is 40 degrees. I will get a saturation temperature of 40 degrees. How do I get that? Based on my coil here. So once I get that temperature of 40 degrees on my gauges here, and then we can record those temperatures. Now, we want to go ahead, anything above 40 degrees will be considered superheat. Because superheat means above, so anything above your evaporator saturation temperature. If it's 41 degrees, it has 1 degree of superheat. 42, 2 degrees, and so forth. Now, I'm going to be, on my next video, I'm going to be putting up what type of range of superheat that you want to maintain. If you have a fixed orifice, you want to have a 5 degree of superheat, 5 to 10 degree of superheat. Thermostatic expansion valve, you want to have a 15 degree of superheat. All right, so guys, this will conclude my demonstration of the refrigeration cycle in the lab. Until next time, we out. Stay safe. Peace.